everyone, welcome to our online video tutorial series. Today we will discuss class 11 maths topic trigonometric functions. Dear students, in class 9 also you are aware about the trigonometric ratios. We will extend the concept of trigonometric ratios to now trigonometric functions. So let's start. So first let's interpret the word trigonometry. The word trigonometry is derived from the Greek word trigon and metron, and it means measuring the sides of a triangle. So initially the trigonometry was introduced with the measuring of the sides of a triangle. The subject was originally developed to solve geometric problems involving triangles. It was studied by sea captains for navigation, surveyors to map out the new lands, and by engineers and others for this purpose. You also solve problems based on the height and distance in class 9 and 10. Currently, trigonometry is used in many areas such as the science of seismology, designing electric circuits, describing the state of an atom, predicting the heights of the tide in the ocean, analyzing a musical tone, and in many other areas. Or you can say that in every space of life, now we are using, knowingly or unknowingly, we are using trigonometry. So we will generalize the concept of trigonometric ratios to trigonometric functions and study their properties. So let's start. First of all, we will discuss about the word angle. So angle is a measure of the rotation of a given ray about its initial point. When a ray rotates about its initial point, that creates an angle. So let's see. This is the initial OA is my initial site. When this OA is rotate towards the B, that means in the counterclockwise direction. Remember, in maths, we will take counterclockwise direction as a positive direction. So that angle will be a positive angle. And whenever we will move from vertex, this is initial side, if I move towards the clockwise direction, that will be treated as a negative angle. So this is the initial position of a ray. If I rotate this in the counterclockwise direction, that is the positive direction, you can see that my angle start taking form 35 degree. Like that, this is a right angle. Then 180 degree angle is known as the linear angle. Now the reflexive angles, and if we keep on moving, and one complete rotation will make the angle of 360 degree. That means one complete rotation, that you can see that this is, if I rotate like this in counterclockwise direction, one complete rotation will be of 360 degree. Now let's understand the units of measurement of an angle. How do we measure the angles? Basically there are two ways, degree measure, and the second is the radian measure. Degree measure. So one complete revolution, as we seen right now, this is my ray, initial point vertex O, and let this is A. If I rotate this row completely about this vertex in anti-clockwise direction, and whenever it will reach to its initial position, that the complete rotation will be of 360 degree. Linear angle means half of the complete angle, means when the rays are just opposite to each other. When this OA will become OA dash, that just opposite to this is known as the linear angle. When they will form a straight line, when they will form a line, then it will become a linear angle. Right angle is the half of the linear angle. That means this is initial line OA, and this is my right angle 90 degree. 1 degree, that means 3/60th part of a complete angle. 1 by 3/60th part of a complete angle will be equal to 1 degree. And 1 degree will be equal to 60 minutes. That means, for an example, if I do the 60 part of 1 degree, let us suppose that this is angle 1 degree. If I do 60 part, then its 1/60th part will be equal to 1 minute. So 1 degree is equal to 60 minutes, and this is a symbol to represent the minute. and 1 minute is equal to 60 seconds. Dear children, these minutes and seconds are not the minutes and seconds we use to measure the time. These are the exclusively used for measuring the angle in degree measure. What is a radian measure? Angle subtended by the center by an arc of the length 1 unit in a unit circle. That means if my circle is a unit circle, then angle subtended by an arc length of 1 centimeter, 1 unit, radius is also 1, then this angle is known as the 1 radian. Let's understand it more clearly. So here I have taken the circle of radius 5 centimeter. So whenever this 5 centimeter arc will subtend an angle at the center, that will be equal to 1 radian. That means whatever is the radius, the arc length of the same size subtends the angle at the center is known as the 1 radian. So now I am shifting this 5 centimeter length to the circumference. So slowly you can see that, observe that I am making the arc length equal to the radius. So this is 5 centimeter now. The angle subtended at center is 1 radian. And if my radius is, for an example, let my radius is 3 centimeter. Then arc length of 3 centimeter will make the same angle. So let's make with the 3 centimeter. So now this 3 centimeter arc length will make the angle 1 radian when radius is also 3 centimeter. Means whatever is my radius, let it is r, then the arc length of r centimeter will subtend an angle of 1 radian. It is to be written as 1 and the small c there. So let's find out the relation between arc length and the radian measure. And this, I shifted this red line that is equal to radius on the circumference. So this is equal to 1 radian. If I shift the again this yellow line, that is again the radius, that will be equal to angle subtended at the center is now 2 radian. Now it is 3 radian. As many radius, this is equal to 3 radius, so they will subtend at the center how much angle? 3 radian. So if my arc length will increase, if I divide this arc length, this is arc length equal to 3 radius. If I divide this 3 radius by radius, then it will be equal to 3. That means angle will become 3 radian. So on, if I keep on substituting this radius, it will become now 4 radian. Now it is 5 radian, 6 radian, and then remaining portion is equivalent to 0.28 radian. So this total will become, this is 1, 2, 3, 4, 5, 6 and 6.28. So I got that whatever is the arc length, if I divide by radius, that will be equal to measurement of the radian. Angle subtended by arc on the center. This is theta radian. L is the length of arc and R is the radius of the circle. So there I saw that complete was 6.28, arc length was equal to 6.28 radius. So this is equal to circumference. That is L. L was 6.28. And if I divide this L with R, so if I divide with R, it will become, R will be cancelled, 6.28, which is equal to 2 into 3.14, or you can say that it is 2 into pi. So theta radian will be 2 pi. That means the complete angle, where in degree measure we say that it is 360 degree, here we will say that it is equal to 2 pi. So 2 pi is equal to 360 degree or you can say pi radian will become 180 degree. This is very important relation between radian and degree. So 1 radian will be equal to 180 by pi. So 1 radian is approximately 57 degrees 16 minute. And 1 degree is approximately 0.01746 radian approximately. So we have to find out, we have to convert this degree measure into radian measure. So how we'll convert? First 30 degree. So as we know that 180 degree is equal to pi radian. So 1 degree will be pi by 180 radian and 30 degree will become pi by 180 into 30. That is pi by 6. So 30 degree is pi by 6, 60 will be double of that. That is pi by 3. 90 degree will be 3 times of that. That is pi by 2. Then again 120 will be double of 60. 2 pi by 3. Then 180 we can write down. Double of 90. Pi 180 degree is equal to pi radian and 360 degree will be equal to 2 pi radian. Now what else we can write down? 30 and 150. It is 5 times. So 5 times of 30 degree. 5 times of pi by 6. 5 pi by 6. 210. That means 180 plus 30. 180 degree plus 30 degree. What is 180 degree? Pi. 30 degree is pi by 6. So it will become 7 pi by 6. 7 pi by 6. Now 270 degree. 270 degree we can find out 210 plus 60 degree one way, or we can find out 90 3 times of the 90. So 3 pi by 2. Then if I have to find out this 300 degree and 330 degree. So 2 pi minus 30 degree. 2 pi minus pi by 6 will give me 330 degree. So it will become 11 pi by 6. And 2 pi minus pi by 3, that is 60 degree, will give me 5 pi by 3. Because pi by 3 is 60, 65 is a 300. So remaining are in the multiples of 45 degree. So what we will do, as we know 90 is pi by 2, then 45 will become half of that, pi by 4. So half of 90, pi by 4. 135 is the 3 times of 45 degree, that is 3 pi by 4. And 225 is the 5 times of the 45 degree, so 5 pi by 4. Likewise you can find out, or we can use this direct method, that 1 degree is equal to pi by 180 radian, and whatever degree I have to find out, for example I have to find out this 270 degree, so I will find out like this. So pi by 180 into 270, cancel it, 9 2 is 18, 9 3 is 27, so 3 pi by 2. But children, try to learn them angles in the radian measure. That will be more beneficial. And radian measure, let's find a relation with them more dynamically. So you can see that my circle is having 0 degree showing here, and this line is representing 0 degree. When I rotate this, so it will be 15 degree, that is equal to pi by 12 radian. So on 30 will become, it's a multiple of 15. So 30, that means 2 pi by 12, that is pi by 6. If we move on, 45 degree will become pi by 4. And then 60 degree will be 4 pi by 12, that is pi by 3. If we keep on rolling like this, and if I move up to this value, you can see that I am exactly at the middle of the circumference. Half of the circumference you can see here, half of the circumference is gone. So angle made by half of the circumference on the center will be 180 degree, that is equal to pi by pi. And if I completely rotate this circumference, then again when it is complete 360 degree, it will be at 2 pi. So now find the radian measure corresponding to the following degree measure. So first we will find out the radian measure for 25 degree. As you know that 180 degree is equal to pi radian. So 1 degree will become pi by 180 radian. And 25 degree will become pi by 180 into 25. So 5 5 is 25 and 5 3 is 15, 36. So my answer will be 5 pi by 36 radian. So let's do the second part. This is minus 47 degree 30 minute. So minus 47 degree 30 minute. So first what we will do, we will convert this the entire term in the degree measure. So this 30 minute we will convert into degree measure. And as we know that 60 minute is equal to 1 degree. So 30 minute will become half degree. So I can write down minus 47 degree 30 minute as minus 47 and half degree. This 30 minute is written as half degree and it will become 94 plus 1 minus 95 by 2 degree. Okay, now let's convert into radian measure. And as we know 180 degree is equal to pi radian and 1 degree will be pi by 180 radian. So minus 95 by 2 degree will become pi by 180 into minus 95 by 2. Let's cancel it. It will be 19. It will be 36. So 19 pi and this is 72. So minus 19 pi by 72 radian. And the third part is 240 degree. So convert that directly. Similarly, we know that 180 degree pi radian, 1 degree pi by 180 radian. So 240 degree will become pi by 180 into 240. So cancel it. 0 and 0 cancel. 6 4 is 24 and 6 3 is 18. So answer will be 4 pi by 3 radian. Now find the degree measure corresponding to the radian measure. Reverse way, we will now convert the radian measure into degree measure. So first 7 pi by 6, and we know that 7 pi by 6. So pi radian is equal to 180 degree. So 1 radian will become 180 by pi. And 7 pi by 6 radian will become 180 by pi into 7 pi by 6. So pi and pi cancel. 6 3 is 18. So 30. 30 into 7, 210 degree. Next is 11 by 16. So let's convert 11 by 16 radian, because see no symbol is there, it is understood that it is written in the radian measure. So 1 radian will be 180 by pi and 11 by 16 radian will become 180 by pi into 11 by 16. Let's put the value of pi. 22 by 7, 22 by 7. So let's cancel it. 1, 2. And then with 2 it will become 90, 8, 45. 45 into 7, 315 by 8 degree. So, but in degree measure, we have the smaller units also available. So let's convert this degree in the minutes and seconds. So first of all, 315 I will divide by 8. So 8 3 is a 24. So will be 7 and 5. 8 9 is 72. So I can say that this is 39 complete degree. 39 complete degree and remaining 3 by 8. 39 degree and 3 by 8 degree we will convert into minute. So whenever I have to convert into minute, I will multiply by 60. So 4 2 is 8, 15, 45 by 2. I can say that 39 degree and 45 by 2 minute. So again we will convert into the smaller units. 39 degree 45 by 2 means 22 and a half minute. And this 22 and a half minute can be written as 39 degree 22 minute and half minute is equal to 30 seconds. So our answer will be 39 degree 22 minute and 30 second. So we will keep on converting into the smaller units in the minutes and second until this fraction exists. Next is minus 4. Minus 4 radian. And 1 pi radian is 180 degree. 1 radian will be 180 by pi. So minus 4 radian will become 180 and place the value of pi. This is 22 by 7 and minus 4. And on simplification, I get 11, 90. So multiply them minus 2520 by 11. So convert them into smaller units. So again, on the same way, I will divide this 2520 with 11. 11 to the 22. So again 22 and 11 nines are 99. So 229 complete degree I have now, and 1 by 11 degree in the fraction I have now. So 229 degree and 1 by 11 degree. So convert into minute. 1 by 11 will be written as 229 degree. 1 by 11, if I convert into minute, multiply by 60. That means 60 by 11 minute. And 60 if I divide by 11, 11 5 is 55. So I can say that it is 229 degree. 60 by 11 can be written as 5 complete minute, and 5 by 11 minute we will convert into seconds. How? Multiply by 60 again. So it will become 300 by 11. 229 degree, 5 minute, and 300 by 11. So 300 if I divide by 11, 11 to the 22, 8 0. 11 7 is 77. So approximately it is 27 second or 28 you can say. So it's approximately 27 second, and the remaining fraction now will leave because we will not go into much smaller units. So my answer will be minus 229 degree, 5 minute and 27 second. A wheel makes 360 revolutions in 1 minute. Through how many radians does it turn in 1 second? So revolutions made by wheel in 60 seconds is 360. So in 1 second, how many revolutions it will make? 360 divided by 60. So it will become 6 revolutions, 6 rotations. So angle turned by wheel due to 1 complete revolutions will be 2 pi. And if we take 6, then it will become 2 pi into 6, that is 12 pi. And we have to find in the radian, that's our answer. So total angle made by wheel in 6 complete rotation will be 12 pi. Find the degree measure of the angle subtended at the center of a circle of radius 100 centimeter by an arc of the length 22 centimeter. So this is my circle, radius is given 100 centimeter and arc length is, this L is 22 centimeter. So here radius 100 and arc length is 22 centimeter. We know that theta radian is equal to L upon R. Let's put the value. So L is 22, R is 100, so 22 by 100 radian. But he asked to find the angle in degree measure. So we have to convert the radian into degree measure. And as we know, the relation is pi radian is equal to 180 degree, and 1 radian will be 180 by pi, and 22 by 100 radian will become 180 by pi into 22 by 100. Let's put the value of pi. So pi will be 22 by 7, and let's cancel out them. 22 and 22 cancelled, 0 and 0 cancelled. So 2 5 is 10, or we can write it like this: 10 if I keep, 18 7 is 126 by 10. So 126 by 10 means 12 degree and 6 by 10 degree. 6 by 10 degree means convert into minutes, multiply by 60. So it will become 36 minutes. So angle is 12 degree and 36 minutes. In a circle of diameter 40 centimeter, length of chord is 20 centimeter. Find the length of minor arc of the chord. So this is circle. AB is my diameter of length 40 centimeter. This is the BC is my chord of 20 centimeter. This OB is radius, OC is radius. As diameter is 40, so radius will be 20 centimeter. So this radius is 20. This radius is also 20 because radius of the same circle. So OBC become an equilateral triangle. So every angle of an equilateral triangle will be 60 degree, or you can say it is pi by 3 radian. Why I converted into radian? Because I know the relation that theta radian is equal to L upon R. So whenever I will write the relation here, I will use the angle in the radian measure. So L will become R into theta. So let's put the value. What is theta? Pi by 3. R is 20. So put the value of pi by 3. Pi is 22 by 7. So in on simplification I got 440 by 21. So which is 20 and 20 by 21 centimeter is the arc length. This is the value of L. In two circles, arcs of the same length subtends angles 60 and 675 degree. So there I have taken two circles of the radius R1 and R2 and let this arc length are equal in both the cases. This is L and let this is also L. We have to find the ratio of their radii, that is we have to find out R1 ratio with R2. So angle subtended by the first circle is 60 degree. This is 60 degree and 60 degree can be written as pi by 3 radian. And angle subtended by the second one is 75 degree. So as we know that 75 degree is the 5 times of 15 degree and 15 degree is pi by 12. If you remember the value of 15 degree pi by 12, you can find any, most of the radian measures we use is multiple of 15. 15 degree, 30, 45, like that 60. So we can find every value. 75 degree will be equal to 5 pi by 12. So length of arcs are same, let it is equal to L. Then we know that L is equal to R theta. Now the first case, in the first circle I am talking about. So R1 R is equal to R1 and theta is pi by 3. So R1 into pi by 3. This will become the arc length. L will be equal to R1 into pi by 3. In the second circle, R2 into angle, that is 5 pi by 12. R into theta. So from 1 and 2, if I see arc length are equal, this is L, this is also L. So these two also be equal. So R1 into pi by 3 will be equal to R2 into 5 pi by 12. So take the R2 to the left hand side and pi by 3 to the right hand side. 5 pi by 12 into pi by 3 will become 3 by pi this side. So let's cancel, pi and pi cancel, 3 4s are 12. So it will become 5 by 4. So ratio of their radii are 5 is to 4. Find the angle in radian through which the pendulum swings. If its length is, if a pendulum is swinging like this, okay, from this point to this point, and radius is 75 and arc length is 10 centimeter. So R is 75 centimeter, length of arc L is 10 centimeter, and we know that theta radian is equal to L upon R. So 10 upon 75, so which means 5 to the 10 and 15. So 2 by 15 radian. And he asked in the radian only, so that's our answer. So that was our today's class. Hope you enjoyed this. Thank you very much for being with us.